Now let's see the next problem. If a plus b plus c plus d into a minus b minus c plus d is equal to a plus b minus c minus d into a minus b plus c minus d, prove that a is to b is equal to c is to d. They are asking us to prove. So what is given is given a plus b plus c plus d into a minus b minus c plus d is equal to a plus b minus c minus d into a minus b plus c minus d. Now what I'm going to do is I'm going to separate the terms, that is I'm going to bring this term to the left hand side, I'm going to bring this term to the right hand side. So that I'll be getting in this form a plus b plus c plus d by a minus b plus c minus d. This is equal to a plus b minus c minus d by a minus b minus c plus d. So now I have to reduce all the terms so that I'll be getting a is to b is equal to c is to d. So now for reducing the terms, I'm going to apply componendo and dividendo property. So I'll be getting a plus b plus c plus d plus componendo and dividendo property a minus b plus c minus d divided by a plus b plus c plus d minus a minus b plus c minus d. So I'm applying the componendo dividendo property. So numerator plus denominator minus. Similarly on the right hand side, a plus b, if you put bracket then you will not make mistake because it's a big term. A minus b minus c plus d divided by a minus b minus c plus d minus a plus numerator a plus b minus c minus d numerator first I have to write a plus b minus c minus d minus denominator a minus b minus c plus d, applying componendo and dividendo. Applying componendo and dividendo property. So I have applied the property and now I'm going to simplify it. I'm going to reduce the terms. Now let me remove the bracket. A plus b plus c plus d. Since it is positive outside the bracket, so I can write as it is. The terms inside the bracket a minus b plus c minus d divided by the denominator a plus b plus c plus d, negative terms I have to multiply inside, minus a, minus into minus becomes plus b, minus into plus is minus c, minus into minus is plus d. This is equal to a plus b minus c minus d plus positive, so I am writing as it is a minus b minus c plus d divided by denominator a plus b minus c minus d, negative term I am going to multiply inside, minus a, minus into minus is plus b, minus into minus is plus c and minus d. Now let me simplify this. I'll be getting, now here I can see b plus b and minus b, so I can cancel and then plus d and minus d I can cancel. Denominator, if I take a and minus a, I can cancel. C and minus C, I can cancel. Now coming to the right hand side here, minus b plus b I can cancel, and minus d plus d I can cancel this. So denominator, if I take minus c and plus c, I can cancel. A and minus a, I can cancel. So remaining terms I have to combine and write. Now here I can see a plus a, so 2a c plus c. So I get 2c plus 2c divided by denominator I am getting 2 times b, 2b and 2 times d. So 2d. This is equal to, in the right hand side, 2a minus c and minus c, so minus 2c divided by denominator 2 times b and 2 times minus 2d. Now I can see 2 is common in both left hand side and right hand side, so I can cancel, or if you want you can take 2 outside and then you can cancel it. So I'm going to cancel directly. So I get a plus c by b plus d is equal to a minus c by b minus d. Now, if I apply componendo and dividendo property to this term, I'll be getting a plus c plus b plus d. So we cannot cancel any of the terms. So what I'm going to do is I'm going to apply the alternando property. I'm going to alter this too. So if a minus c comes to the denominator, and if I apply componendo and dividendo, this a terms or c terms will get cancelled. So I can simplify it. So I'm going to apply the alternando property, and I'm going to bring this a minus c to the left hand side, so it comes to the denominator, and b plus d I'm bringing to the right hand side, it comes to the numerator. Applying alternando property, just altering, just changing the numerator, right side numerator to the left side denominator. I'm getting this. Now I'm going to apply the componendo and dividendo property together. So I get a plus c plus a minus c by a plus c minus a minus c. Left hand side, right hand side, b plus d plus b minus d divided by b plus d minus b minus d. Applying componendo and dividendo property. Each time you should write which property you are applying. So here I am applying componendo and dividendo property together. Now let me simplify this. A plus c plus a minus c. Denominator I get a plus c minus a plus c. So this is equal to b plus d plus b minus d divided by b plus d minus b plus d. Now let me cancel the common terms. Now here I can see c plus c and minus c can cancel. Denominator a and minus a can cancel. Here in the right hand side, plus d and minus d I can cancel. B and minus b. So I am getting 2a by 2c is equal to 2b by 2d. Now 2 is common, I can cancel 2. I'll be getting a by c is equal to b by d. Now what they're asking us to prove is a is to b is equal to c is to d. So now I'm going to apply the alternando property. Just I'm going to change this so that I'll be able to prove what is asked. So I'm getting a by b is equal to c by d. Applying alternando property. Applying alternative property, I have interchanged B and C. Now I can write this as A is to B is equal to C is to D. This is what they're asking us to prove, and so we have proved it, hence proved. Now let's see the next problem. If A minus 2B minus 3C plus 4D by A plus 2B minus 3C minus 4D is equal to A minus 2B plus 3C minus 4D by A plus 2B plus 3C plus 4D, show that 2AD is equal to 3BC. So this is given and they're asking us to prove 2AD is equal to 3BC. So now what I'm going to do is I'm going to apply the componendo and dividendo property together to simplify it and to reduce the term and to show that 2 times AD is equal to 3BC. Now I'm going to apply the componendo and dividendo property. So A minus 2B minus 3C plus 4D plus the denominator term A plus 2B minus 3C minus 4D divided by A minus 2B minus 3C plus 4D minus the denominator term A plus 2B minus 3C minus 4D. This is equal to, coming to the right hand side, A minus 2B plus 3C minus 4D plus the denominator term A plus 2B plus 3C plus 4D divided by A minus 2B plus 3C minus 4D minus A plus 2B plus 3C plus 4D. So I have applied a componendo and dividendo property together. Componendo and dividendo property I have applied both the left hand side and the right hand side. So I have got this. Now I am going to simplify it. So if I simplify the numerator term, I am writing as it is because it is with the positive term, the plus term. So I can write as it is plus A plus 2B minus 3C minus 4D. Denominator term, I have to multiply the negative term inside. So A minus 2B minus 3C plus 4D. Let me multiply the negative term inside. So I get minus A minus 2B plus 3C plus 4D. This is equal to A minus 2B plus 3C minus 4D plus A plus 2B plus 3C plus 4D divided by A minus 2B plus 3C minus 4D. Negative term, I'm going to take it inside the bracket. I get minus A minus 2B minus 3C minus 4D. Now I'm going to cancel the common terms in the numerator and in the denominator. I get minus 2B and plus 2B I can cancel, and plus 4D and minus 4D I can cancel. The denominator A and minus A, minus 3C and plus 3C I can cancel. Coming to the right hand side, I can cancel minus 2B plus 2B, minus 4D and plus 4D I can cancel. In the denominator, A and minus A plus 3C and minus 3C. Now I am going to write the remaining terms. Now here A and A, so 2A and minus 6C. Denominator I get minus 2B and minus 2B, so minus 4B and plus 8D. So this is equal to right hand side 2A plus 6C divided by, here minus 2b, I get minus 4b and minus 8d. Now I'm going to interchange 2a minus 6c and now I can take the common terms outside. So here the common term, minus 4, I can take it outside. I get b minus d. Similarly in the numerator I can take 2 outside. So I'll be getting 2, if I take it outside I get a minus 3c. So denominator I have taken minus 4 outside, I get b minus 2d. Okay. So I have taken the common term outside. So here also I am going to take the common term 2. I am going to take it outside. I get a plus 3c divided by minus 4. I am taking it outside. I get b plus 2d. Okay. Now I am going to cancel the common terms. Here 2 gets cancelled. Minus 4 and minus 4 gets cancelled. So I am getting a minus 3c by b minus 2d. In this term, a plus 3c by b plus 2d. Okay. Now I am going to apply the alternative property. So I am going to change these two terms. Applying the alternative property, I get b plus 2d by b minus 2d is equal to a plus 3c by a minus 3c. Now I am going to apply componendo and dividendo property to simplify further. So b plus 2d plus b minus 2d divided by b plus 2d minus b minus 2d. This is equal to a plus 3c plus a minus 3c divided by a plus 3c minus a minus 3c. Applying componendo and dividendo property together. Applying componendo and dividendo property. We have got, now we are going to simplify it. So in the numerator, I get b plus 2d plus b minus 2d divided by b plus 2d minus b plus 2d. This is equal to a plus 3c plus a minus 3c divided by a plus 3c minus a plus 3c. Now let me cancel the common term. Now here my plus 2d minus 2d I can cancel. In the denominator I cancel b and minus b. Here plus 3c minus 3c, a and minus a I can cancel. So the remaining terms, here b plus b, so 2b, here 4d. This is equal to 2a by 6c. Now I can cancel again the common terms. I can cancel 2 and 2 I can cancel. 2 times 2 3 times. So now I am getting b by 2d is equal to a by 3c. Now let me cross multiply. I'll be getting 3bc is equal to 2ad. So this is the thing they're asking us to prove. Now we have proved it. 2ad is equal to 3bc. Hence proved. So we have proved 2AD is equal to 3BC. Now let's see a problem. If a square plus b square into x square plus y square is equal to ax plus by the whole square, prove that a by x is equal to b by y. So first what is given, let me write. A square plus b square into x square plus y square is equal to ax plus by the whole square they have given. So they are asking us to prove a by x is equal to b by y. They are asking us to prove. So now let me simplify this. So first let me multiply a square into x square. I'll be getting a square x square plus a square into y square, a square y square plus b square into x square, b square x square plus b square y square. This is equal to, now I'm going to use a plus b the whole square formula, that is, a plus b the whole square is equal to a square plus 2ab plus b square. So I'm going to use this formula here. A square, that is, now in the place of a we have ax, so ax square plus 2 into ax by plus by the whole square. Now this can be written as a square x square, I'm writing it as it is, a square y square plus b square x square plus b square y square, written as it is. Now here I'm writing a square x square, I'm taking the square separately to the terms, plus 2ax by plus b square y square. Now let me cancel the common terms, or otherwise I can bring all the terms to one side and then I can cancel. A square x square plus a square y square plus b square x square plus b square y square minus, I am bringing the terms to one side, so I am bringing a square x square to left hand side, so it becomes negative a square x square minus 2ax by minus b square y square is equal to 0. Now let me cancel the terms. A square x square and minus a square x square I am cancelling, and then b square y square here minus b square y square I am cancelling. So remaining terms I am going to write a square y square plus b square x square minus 2ax by equal to 0. Now a and y, so I can write this as a y the whole square, let me write it like this, plus bx the whole square minus 2 a is with y, so I'm going to write it like this so that it will be easy, into ax ay with a and y into bx is equal to 0. Now I can see this, it is nothing but a square plus b square minus 2ab formula. See, a minus b the whole square. Here, what is the formula for a minus b the whole square? A square plus b square minus 2ab. Now you can compare and see this formula. In the place of a we have ay the whole square. In the place of b we have bx the whole square minus 2 into ab, 2 into ab. So 2 into ay into bx equal to 0. So I can write this as ay minus bx the whole square is equal to 0. Now ay minus bx the whole square is equal to 0 means this implies ay minus bx is equal to 0. Now ay is equal to bx I can write. Next, a by x I am bringing to the left hand side, so it comes to the denominator, which is equal to b by y I am bringing to the right hand side, it comes to the denominator. A by x equal to b by y. So this is the thing they're asking us to prove. So we have proved a by x is equal to b by y, hence proved. Next problem. If a, b and c are in continued proportion, prove that a square plus ab plus b square by b square plus bc plus c square is equal to a by c. Now what is given is, given a, b, c are in continued proportion. A, b and c are in continued proportion. They have given continued proportion. That means a is to b is equal to b is to c. So this is the thing they have given. A, B, C are in continued proportion. Therefore, a is to b is equal to b is to c. Now I can write product of the means is equal to product of the extremes. So b square is equal to ac. So given, from the given condition I have taken b square is equal to ac. Now what they are asking us to prove is, to prove a square plus ab plus b square by b square plus bc plus c square is equal to a by c. They are asking us to prove. So I'm going to take the left hand side and I'm going to prove it is equal to right hand side. Proof, consider the left hand side, that is a square plus ab plus b square by b square plus bc plus c square. So I'm going to consider this. I'm going to prove it is equal to a by c. Now this is equal to a square plus ab, b square is ac. So I'm going to substitute instead of b square ac. So plus ac divided by, similarly in the denominator we have b square. So I'm going to substitute ac plus bc plus c square. This is equal to, so I can see in the numerator a is common. Let me take it outside. A into, so first term a square, so I have taken one a outside, so remaining one a is inside the bracket, plus b plus c divided by, denominator I can see c is common, so let me take it outside c. So in the first term a, second term b and third term is c. Now I can see a plus b plus c, and a plus b plus c is common in the numerator and denominator. I can cancel it. So this is equal to a by c. So this is the thing they are asking us to prove, and we have proved it. Therefore a square plus ab plus b square by b square plus bc plus c square is equal to a by c, hence proved.